using square roots to solve quadratic equations. In this tutorial, we're going to look at just two different examples from this section. This is section 3.6 out of our Math 2 book. We're going to look at rationalizing the denominator when it's really not a very nice fraction to start with. And then we're going to look at solving a quadratic using the square root method. If we look at our our fraction, we have 3 minus the square root of 2 over 4 plus the square root of 5. If you remember back from chapter 1, we talked about using complex conjugates. Well, this is not a complex number, but we can still use the same idea of a conjugate. In this case, we have 4 plus the square root of 5 on the bottom. We're going to take that value, we're going to change that sign in the middle. So we have a plus sign here. We're going to change that to be 4 minus the square root of 5. We're going to multiply our top and our denominator, numerator and our denominator, by this expression. If you let it multiply out, you're going to get 12 minus the 3 square roots of 5 minus 4 square roots of 2, and then minus the square root of 10. Remember that if you have a square root times another square root, I can multiply the numbers under the radical, but I'm not allowed to multiply numbers under the radical with numbers outside the radical. If I can simplify that radical, I go ahead and do that. But in this case, the square root of 10 only has factors of 1 and 10 and 2 and 5. None of those which are perfect squares. So we have to leave it. Look at the bottom. When we multiply conjugates, this one does have a shortcut. If you remember, now you can go ahead and you can FOIL the whole thing out just like you would normally do, but you'll notice that every time you do that, the second and third terms always cancel out. And so we're only left with the first term and the last term. So you can kind of go straight to that if you can remember that. So we're going to multiply the first terms together, 4 times 4 is 16, and the last terms, positive square root of 5 times negative square root of 5. That would give me a positive, well, it would give you a negative square root of 25. Well, we know the square root of 25 is just 5. And so we can take that, we can do 16 minus 5 gives me 11. And you notice on the top that I didn't simplify anything. Okay, that's one of the reasons I picked this particular problem. You had a whole number. We have negative 3 square root of 5 minus 4 square root of 2 plus the square root of 10. Every single radical is different. The number under the radical is different. I cannot combine radicals with different values underneath, nor can I combine whole numbers with my radicals. Okay, even if every whole number had something in common with 11, I might be able to simplify that way. But in this case, there's nothing in common. This is my solution. As ugly as that may be, it's still my solution. Okay, so that would be basically what we're trying. The goal of that entire process is to get the radical out of the denominator, and we succeeded that here because we simply have radicals in our numerator when we got thing left over. One last little example and we'll be done. Solving equations using the square root method. Basically, you're going to take a quadratic. This works very well when you have things in vertex form that's already kind of got a part that's squared. Basically, you want to get everything on one side of the equation and you're simply left with something squared equals a number. If you can get that far, then this is a perfect candidate for using the square root method. We're going to learn a lot of different methods over the course of this chapter in how to solve square roots. And so you want to start identifying when should I use each method. In this case, we're going to start off by adding 1 to both sides to get this part over here, because I've got to get rid of the negative 1, I've got to get rid of the 1/3. So we'll do that first. This gives me 6 on this side. The next step is to get rid of my fraction. And to get rid of a fraction, of course I can divide by 1/3, but it's a lot easier to think of it as I'm going to multiply by the reciprocal. So I'm going to multiply both sides by 3 over 1. That gets rid of this fraction, and 3 times 6 is 18. Now you've got it exactly where you want it. This is where we take the square root. This is the key step. I'm going to take the square root of this side. Simply my squared goes away. When I take the square root of the number, if you can simplify the square root of 18, you go ahead and you do that. Okay, remember when you take the square root of a number, it's always plus or minus, because you're not sure if it's negative or positive to start with. So these are both possibilities. And so we take that plus or minus 3 square roots of 2. Remember, it's 9 times 2 to get 18. So the square root of 9 is 3, and that's why the 3 comes out front. We go ahead. We've got a 4 here. We're going to go ahead and add 4 to both sides, or subtract 4 from both sides. And I get x equals negative 4 plus or minus 3 square roots of 2. Notice that this can't be simplified any more than it is. And these are the two solutions for my quadratic equation. You will always have two solutions for a quadratic. That's why you have an exponent of 2, indicating 2 roots, or 2 solutions. And that covers rationalizing the denominator and solving using the square root method.